Hi lads, in this video I'm going through the 2016 section B1. It tells us the image on the right shows a restaurant which consists of a series of intersecting triangular glass surfaces. Figure B1 shows the plan and elevation of 4 such intersecting planes. Data related to the horizontal and vertical coordinates for points A, B, C, D, E and F, defining the 4 planes, are also given. So basically, there's our coordinates, there's our elevation and plan, and we can see here the height of F is actually missing, so at some point we want to try and figure that out. Part A, draw the given plan, the 4 triangular planes, and complete the elevation of the intersecting planes ABC, ABD and DEB. Part B, determine the dihedral angle between the planes ABC and ABD. Part C, draw the elevation and plan of a horizontal line on the surface DEB, and then determine the true inclination of surface DEB to the horizontal plane. And then part D, the dihedral angle between the planes DEB and DEF is 170 degrees. Complete the projections of the surface DEF. So basically that last part there, if you're able to find the dihedral angle, which you're told is 170, you'll be able to get that height then as a result by taking your views back. So I already had the question set up there. You can see that I have my coordinates. And what I did was, just to make sure I have enough space on the page as best I can, I would have come in from the left hand side about 100 mil, and I would have stepped down about 95 mil and started at that point as 100. So for example, for point A, I would have went a further 30 mil out to give me 130. And then same for the rest of the points, just adding on the distances in between. And I'm just keeping my question nice and high up on the page. So that's part A then complete, just basically drawing out all your points, except for point F. We can see that point F in the plan there, we're given the dimension. But for F going up here, we do not know the height of it yet. We need to figure that out and just label that as Y. So, part B then, determine the dihedral angle between planes ABC and ABD. So we're looking at this plane here, which is same here in plan. So the first thing, as always, we look at what's common between the two. And we can see clearly, if I write it out, just ABC and ABD, A and B are common between the two. So the first thing we're going to do is look perpendicular to AB, see the true length of it. When we see the true length of any line, and then we look perpendicular to that, we see as a point view, which will give us an edge view as a result of the two surfaces to give us the dihedral angle. So we have AB, and we go in perpendicular to that first. So for this question here, I'm going to take it up to this side, because I can see from later on the question, I'm going to have to take another auxiliary view, which will have space down below, and to go up to the right then to solve after this. So I extend out points A, B and C here, and then point D as well can be included. And I'll just keep my XY line nice and close to it there then. And this is going to be my X1, Y1 for my first auxiliary view. So as always, we go 2 views back, 1 view into our plan, 2 views into our elevation. We get the height of A here, there's the height of A, follow it down, follow it up, there's point A. B and C are the same heights, so I can just take the height of C here, follow it down, follow it up, there's the height of C, and then for B as well, it's the same height. I can take this, mark it there, and I just need to extend out B this way. So there's B, C, and then finally D is the last point. There's the height of D, follow it down and follow it up. Now I can connect the planes together. So there's planes ABC, and then we have AB, and then finally back to D. So the key thing I have here, I'll just use colour to show. There's the true length of AB. And when I have the true length, if I look in perpendicular to that, I'll see it as a point view. So I need to go downwards. So I take AB here, extend it down, slide it up to get point C, and slide to this side to get point D, and I'll draw my x2, y2 about here. Label that x2 and y2. And once again, two views back. One view into my first auxiliary, two views into my plan. So the way I prove as well, I'm going to get a point view and I've looked in the right direction. I have A and B appearing as the same distance. A and B are taken from the same line. So A and B appear as a point. So there's AB there. Next one I'll take is C, that distance there, follow it up and down. There's C. And then finally, D is the farthest point away, follow it up and follow it down. And there's point D. Connect those together then. Now it tells me as well to determine and indicate. So determine the dihedral angle. So what I need to do is just extend this line out here, extend this line out here, and just measure the angle in between. So starting at that 0, it goes all the way around and it goes to roughly, see there, just get it lined up, goes 120, 30, 40, 50, 60, goes to roughly 165 to 166 degrees. And that's the angle I have now in between there. So that completes part B. Determine the dihedral angle between ABC and ABD. Next part then, part C. Draw the elevation and plan of a horizontal line on the surface DEB and then determine the true inclination of surface DEB to the horizontal plane. So we want to find out what is the true angle this plane makes to the horizontal plane as a result. So at the moment we can't see what angle it is because the plane is at all different points there and none of it is actually inclined to the horizontal plane yet. So we want to make it look as if it is. So we've seen from previous questions, what we want to do is we want to take a level line. And it tells you there, you take a level line on the surface DEB. So if we take a horizontal line from E, just move this up, because we know that a level line in elevation, parallel to XY line, is a true length in plan. We take that point down to where it hits, so it hits BD there, so we have to extend it down, hits BD there, and it connects back to E. So that's where we take our level line. We already have a point E, so we can use that and take a level line. And I'll just show using a colour for that line as well. So there's my line. And that then, as a result, is a true length. If we look in perpendicular to that and create our XY line, we can see the true inclination of that plane, because when we look in perpendicular to a true length, we see it as a point. So if we see that line as a point, that means we're going to see the plane as an edge view. If we imagine that being, if I set up my set square like the way the question is, there's a level line there in elevation. If we look perpendicular to it, we can see it as a point, and if I just hold it there, you can see then, we can see that edge there as a line, and that gives us a true inclination as a result. So we take that up this angle here. So we need D, E and B. We already have E here and B there. Now we just need D there. And then we go perpendicular to that to get our XY line. I'll keep my XY line around here. So we have another X1, Y1 there as a result. And as always, 2 views back. 1 view back into our plan, 2 views into our elevation. Take the height of D, follow it down, follow it up. There's D there. The height of E, follow it down, follow it up. And then F. Sorry, we don't have F, we only have D and E, so we can join those together then. And that gives us our edge view. So there's our edge view then there as a result. And what we can do then is, we can just extend that down. Extend our XY line out. And now we can get our angle there as a result. So where the line extends down that plane, where it hits it, it gives us our angle. So just measure that there then as a result. Sorry, it was DB, so I should be taking the height of B. So you'll see there, follow B down, follow B up. And you'll see when I extend these out, it'll still hit off it. You can see there, still on the same line. So it just proves. There we go, DB, I was reading the wrong plane. So still we extend that line out, and now we can check our angle. So our angle there is roughly working out to be about 50 to 51 degrees. So I'll just leave it about 50. So 50 degrees there for our angle it makes to the horizontal plane. And then we have the last part. So we're told the dihedral angle between the planes DEB and DEF is 170 degrees. Complete the projections of the surface DEF. So they're telling you it's 170 degrees. So if they're telling you what angle it is, what we need to basically do is find our 2 auxiliaries and then measure using one of our edges to find the 170 degree angle. It's like basically doing this here, taking an auxiliary to get our true length, looking in perpendicular. The difference is, for example, we could be missing point D, and because we're told it's 170, or in this case for this question 166, we could measure 166 and extend our line out here to find where it ends. And that would give us point F as a result. So that's what we have to do with this one. We need to basically draw our auxiliaries and use the information given to us, basically the dihedral angle, to solve the rest of the question, which will give us point F. So the first thing we need to do is, we need to find out what's common between the two. So if I just write them out there, it's DEB and DEF. So if I just have DEB and DEF, I can see the 2 common things there are D and E. So that's the first auxiliary I'm going to take. I'm going to look in perpendicular to DE to see the true length of that first. So it's DEB and DEF. And in plan we're already given it. We're given that distance there. So our auxiliary view, I'll just take my XY line about here. There's our X1, there's our Y1. And as always, we go 2 views back. So 1 view back into our plan, 2 views back into our elevation. So there's D first, follow D down and D out. Just need to extend my lines first. And Just make sure I have enough room for all of them. So there's D now marked off. Then I have E. Take that down and take it out. So there's DE. And there's the true length of that line. And then we have B. Follow B down and out. So there's triangle DEB. And we can't find point F, we don't know how high it is up, so we just leave F taken out here. So somewhere along that line is going to be point F. And when we get that from our second auxiliary, we'll be able to take the height from F and reapply it backwards. Because for example, this height here is the same as this one. When we find our auxiliary view, which will show us our dihedral angle, we'll be able to apply that then as a result. So now we need to look in perpendicular to DE. So if we take DE here, what I'll do is I run out of space on this side. I'll take B up here as well. Need to just mark it back this way. I'll just keep it nice and close to this side here. That's my next auxiliary. I'll just mark that as X2 and Y2. And what I need to do then is I need to go 2 views back. So as I said to you before, you can't see that, just 1 sec, I'll just move that down a bit. So I just basically took my heights from here and applied them out here. And I'm now taking my next auxiliary, looking in this way here. So I can see DE as a point view, and I'm told my dihedral angle is 170. Now because I have very little space left on my sheet, what I'm going to do is, I'm going to take a measure line. So we did this before where we take our X1, Y1, and move it back. So I'm going to have it touching off point F. Just move it back there. So I'm going to have it touching off point F, and that's my measure line. I'm going to take my distances from there instead, because if I take these distances, I'm going to go off my page as a result. So as always, we go 2 views back, 1 view back here, 2 views back in here. So I measure from my measure line. Take point D. And remember, D and E should be the same because we want to see it as a point view. So those 2 distances are the exact same. We take them down, follow them out. D and E are on the same line there. So we mark that as D and E. B, follow it out there. From our measure line, we take that distance and sign it from here. So I'll just move that over a bit so you can see. So mine is slightly going off the page there. You can see where I've marked off B out there. I just extend it out. That gives me point B there. And then I can join DEB together. I'm told the angle is 170 degrees. So if I take my protractor, line it down at 0, 170 degrees is out here. Connect those 2 together. F is on the ground here, so that means it's going to be on the ground there as a result. So I know where to stop my line, where it hits the X2, Y2. There's my 170 degrees. And now I have point F. And that's the key bit of information I now have. So when I take point F back into the original view, there it is there. F hits F there. That gives me F in my first auxiliary. And remember, all views are measured 2 views back. So if I'm able to take, for example, height D here and apply it here, I can take the height of F from the auxiliary and apply it back up here because I have it in plan, I know where it is, so I follow it up. There's point F then as a result. And now I can complete the question then. And that's how I find the last point for F there. And it doesn't actually tell you to determine the height of F, so I just need to mark it in there. So how I found that, just use a brown colour. I took my height from here, I'll call that H1, and I apply it to here, H1. So hopefully that video helps anybody may have been stuck on that question there.